All right, hello everyone. Today we're taking on Introduction to Control Charts. And I just want to say I'm so sorry. It looks like one of my daughters may have scribbled on my paper. I'm sure it was on accident. Don't want to throw anyone under the bus, but my money is on Scarlett. She's pretty naughty these days. All right, let's start. Every process varies. If you write your name 10 times, your signatures will all be similar, but no two signatures will be exactly alike. There is inherent variation, but it varies within predictable limits. If, as you are signing your name, someone bumps your elbow, you get an unusual variation. If you're cutting diamonds and someone bumps your elbow, this unusual variation can be expensive. For many processes, it is important to notice the causes of variation as soon as they occur. Control charts enable us to examine data over a period of equally spaced time intervals or in some sort of sequential order. When the individual measurements of a variable are approximately normally distributed, control charts can detect processes that are possibly out of statistical control. While there are many subspecies of control charts, all have three basic components. So first we have a center line, which represents the mathematical average of all of the samples plotted. We have upper and lower statistical control limits that define the constraints. We have performance data that's plotted over time. All right, so let's start with this initial example. A major West Coast metal producer received the following complaint from a customer. The customer said that the metal that they had recently received had an impurity in it. The impurity was a trace element in the metal that affected how the metal performed. Since this particular impurity hadn't been a problem in the past, the metal producer hadn't been monitoring it. The metal producer looked up the records on metals shipped recently to that customer. The percentage of the impurity in the metal for each week's shipment is given in the table below. Okay, we're given our raw data here, metal impurity in production. We're looking at it sequentially over time, so we're given week ending June 7th, June 14th, etc. The metal producer graphed the data on a plot over time. We call this a run chart when used for an industrial process. All right, let me pull it up to here. All right, so here is our run chart below. So here, the metal producer checked with its supplier and found that the supplier had substituted a different raw material which contained the impurity in place of its regular raw material. The metal producer now routinely plots impurity levels of all types of impurities so that the customer will be the first to know. So when do you think the metal producer first started using the lower quality raw material? Okay, this one should be pretty intuitive, pretty obvious, right? Somewhere in here, right where we see that big spike in our graph. So somewhere from this span of time, from here to here. So here I'm going to write a little note to self, right in here, a lower quality raw material must have been introduced somewhere between August 30th and September 6th, right? That's what it's looking right there. That's where we see the big spike. It's staying pretty stable here, and then we see a dramatic increase in the percentage of impurity after this point in time. Okay, so I think we already answered it. We said somewhere within the week, 8:30 to 9/6. Okay, also wrote it right up here. All right, companies want to stop production as soon as possible after a process goes out of control. In the case of the metal producer, it was pretty obvious when that happened. Often a process goes out of control much more gradually. What should a company look for in a run chart to indicate its process might have gone out of control? So maybe pause for a moment and think about it. What would you be looking for if you were deeming a process as out of control? Okay, and then unpause and come back to me. So what I would think about would be, any potential outliers. Maybe I see some giant spikes somewhere in my graph. So a potential outlier. And we know that an outlier is a piece of data that really deviates from the rest of the group. It strays from the norm. Okay, so it could be one singular data point that just doesn't make sense. Okay, we could also see a shift of mean. So our center line seems to be shifting upwards, or it could be downwards. But it could also be a shift of standard deviation. So a shift of mean, we're saying that, well, gradually over time, we are seeing a shift upwards or downwards. And if we're seeing a shift of standard deviation, remember, standard deviation is tied to variation, the variability, the consistency. So if we're seeing that our procedure is pretty consistent, and then all of a sudden it gets erratic, where I see values that are high and low and very far apart, right, that would signal that I have a shift of standard deviation. You'll see what that looks like on the next page. Okay, another thing just to look at is some sort of consistent movement in one direction. So some sort of sharp rise or fall. All right. So again, some ideas of what could show that something is out of control, a process is out of control, right? We could have just one data point that just seems really off, that we can't explain. Maybe we can't explain it. Shift of mean and or standard deviation. So a shift of mean, we see that center line, we have a lot of data that is above the center line or below it. Okay, standard deviation, whatever our process is, we're not getting that same level of consistency. We're seeing more erratic data, more data that fluctuates high and low. Okay, and then we also would be wary of any sort of consistent trend that's in one direction. So maybe we see things that are trending high or are trending low. All right, let's flip the page, go to the second one. All right. Here we go. So at Prairie Farms Dairy, a process of filling milk containers is supposed to give a distribution of weights with mean 64 ounces and a standard deviation of 0.2 ounces. The 4 run charts provided come from 4 different machines. For each machine, 30 milk containers were filled and the number of ounces of milk measured. 2 of the 4 machines are out of control. Use the 4 run charts to answer the following questions. Which 2 machines appear to be out of control? So my advice here for you is to focus on the mean and the standard deviation. So if I summarize, we're told that this is approximately normal. So the mean is 64 with a standard deviation of 0.2. So I'm going to go ahead, I'm just going to add in the center line, which is where the mean would be. So my center line, I'm just going to freehand it, is at 64. So I'm just going to draw in a solid line at all of the 64s for each of these graphs. You do the same. A sketch is fine. Okay, oh, my 64 on the bottom. There we go, fixed it. Okay, so here when we're looking at our options, again, we're looking at 2 machines that appear to be out of control. So if I look at machine 2, is out of control. So machine 2 is out of control because we're seeing that data varies from container to container. There seems to be some sort of lack of consistency, right? The standard deviation appears to have increased. So if I look at this, remember what the standard deviation was. It was 0.2. Let me just sign it up a little bit. 0.2. So right here would be one standard deviation. So if we go back to what we know about normal curves, we know that 68% of our data, most of it should fall within those markers. If I go out to 2 standard deviations above and below, here to here, that's 95% of our data. So again, the bulk of our data should be within plus or minus 1 standard deviation of the mean. And the fact that we're not seeing that, so if I kind of trace it out, here I don't see the bulk of my data is between plus or minus 1 standard deviation. I see a bunch of dramatic highs and lows, right? I see more variation than I would like, right? Again, that was the center line where the mean was. So this one is out of control. And again, the language that I used, I said the data varies from container to container, right? There's a lack of consistency. And it appears as though the standard deviation has increased. So because we're seeing data that is more erratic, it is fluctuating more, data is more widespread, that is an indication that the standard deviation has increased. Okay, the other one that's out of control is number 3. So number 3, let me just write that language, out of control. All right, so again, that center line is where the mean is. The mean was 64. So why is this one out of control? Well, it looks like the bulk of the containers have more ounces than the mean, right? So if I look at all my data, most of it is above that center line. So it's giving me an indication that the mean has increased because the bulk of the data is above that center line. So let me write that. Bulk of data is above the center line, and the center line is where the mean is. Okay, if I'm being technical and I counted it out, I'd say that it's 25 out of 30 that are above the center line. Okay, again, this gives me an indication that the mean has increased. Okay, machines 1 and machine 4 appear to both be in control. Here we're seeing data that is kind of evenly dispersed above and below the center line. I don't see a lot of data points that are dramatically high or dramatically low for either of them. So both of those, again, are in control. All right, so again, I have 2 more questions to answer. On which of these machines did the mean change? Right, we're saying 3. Oh, for A, we said 2 and 3. This one has 2 answers. Sorry, let me go back to that. Okay, so the machine appears to be out of control, machine 2 and 3, for the reasons that we just went over. All right, for B, on which of these machines did the mean change? Right, 3, because the bulk of the data was above the center line. The bulk of the data was on one side of the mean. And then where did the standard deviation change? 2. 2, we saw more fluctuation. There was a larger amount of variation. We saw a lot of data that was much more spread out than it should have been. All right, let's flip it over to the next sheet. All right, one test often used is to declare a process out of control when a single value is more than 3 standard deviations from the mean. This test assumes that the individual values are approximately normally distributed If the process is in control, what is the probability that the next measurement will be more than 3 standard deviations above the mean? Okay, so here we're saying, well, if we see something that's like an outlier, right, then we would say that the system is out of control. So we know how unusual it is to have a data point that falls beyond 3 standard deviations of the mean when we're looking at normal distributions. If we visualize it, let's picture the normal curve like so. Here's my normal curve. So here's my mean with a z-score of 0. 0 standard deviations from the mean. And way out in here, deep in the tails, would be a z-score of 3 and a z-score of -3, right? Those represent 3 standard deviations away from the mean. So if I'm looking at this tail and this tail here, okay, here, if I'm using my z-score chart, then I know that the area right here would be 0.0013, and my area here would match it, 0.0013. So if I add up those 2 tail regions, the 2 0.0013s, I get 0.0026 as my probability. Okay, in decimal form, it would be percent form, 0.26%. So decimal form would be 0.0026, and as a percentage, 0.26%. So we know that it would be really, really unusual to see anything past those 3 standard deviation markers, right? We would have a 0.26% probability of that playing out. So very, very unlikely. If instead, if I wasn't using my z-score chart and I was going back to that general 68, 95, 99.7 rule, then it would have been 0.3%, which again, it's still very, 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 very unusual, unlikely for that to play out. All right, so for example 4, each of the following run charts was made from a process that was supposed to be normally distributed with a mean of 5 and a standard deviation of 1. So again, if I summarize that nicely, use my big N, my mean is 5 and my standard deviation is 1. All right, UCL means upper control limit. LCL means the lower control limit. How are these limits computed? So if we look here, the first one, here is that center line, that's where my mean is. Here is my upper control limit, and here's my lower control limit. So I can see that I'm just 3 units above and 3 units below, and my standard deviation is 1 unit, right? So I can say that this right here is my +3 standard deviation marker, and this would be -3 standard deviations. So the upper control limit and the lower control limit are both 3 standard deviations away from the mean. So 3 standard deviations from the mean. So using the test of 3 standard deviations more than the mean, away from the mean, on which chart is there a point where the process should be suspected to be out of control? So if we look at all of our options, right, we're looking at situation 1, 2, and 3, right? We're looking for which one is it, right? It's got to be chart 2. Chart 2 is a big winner right here, that point right there. So it looks like it's observation 15. So observation 15. So here it's out of control on observation 15. Because in this case, we're more than 3 standard deviations below the mean. Okay, so we're saying, oh, that seems unusual. That is very unlikely to play out. It is very abnormal to get a data point that falls above the upper limit or below the lower limit. Collectively, Any data point that falls in this region or in this region should happen 0.26% of the time. If I was looking at just in this region, just in that upper region right here, that would have been 0.13% of the time. Down here, 0.13% of the time as well. So again, it is really, really unusual to have a data point that falls beyond these two regions here and here. So that doesn't mean that we have to stop our procedure necessarily. We do expect that sometimes we get some abnormal data points. We just want to be able to investigate further, see if there's a reason, a good explanation for why this occurred. Is there something else that we need to fix? Or is this something that just happened out of, like 1,000 pieces of data? Well, then we expect that this will play out every once in a while. It's just unlikely, unusual for this situation to play out. It triggers a red flag in the system that just says, investigate further. All right, last page. All right, here we go. So this is a resource I'm going to make for you guys as well. And by the time that we assess next, you will have one of these control chart summaries for you to use on your next exam. Okay, so on the chart, illustration of tests, there are 8 tests used by industry to signal that a process may have changed. The zones are marked off in standard deviations. So for example, if a value falls in zone A, it is more than 2, but less than 3 standard deviations from the mean. Each X marks the value at which a process is first declared out of control. Each of these tests assumes that the individual values come from a normal distribution. So again, I just want to say, I don't expect that you have this whole chart memorized, right? That gives you the illustration of these 8 tests. I will give this to you as a supplement. I just hope that you're able to be familiar with it and be able to identify which test is being mentioned. Okay, so match each of the 8 tests to the best description below. So I would love it if you would take a moment, hit pause, and see if you can match up the test 1 through 8 with its description. And then unpause, and I'm going to go over it. All right, so unpause. So here, looking at the first description, the observations are gradually getting larger or smaller. So here we're saying, where is it that we're seeing this upward trend or downward trend over a period of time? So observations getting gradually larger or smaller should be test 3 right here. So I see this gradual increase or gradual decrease over a period of time. So A would be test 3. Okay, for B, one observation is very far from the mean, and that's really the situation that we just saw in example 4. So where do we see that one data point that is exceptionally high or exceptionally low? Beyond zone A. So zone A, right, that right there is the upper control limit, the lower control limit. So we're saying these points are beyond 3 standard deviations of the mean. So that's test 1. All right, 2 of the 3 observations are unusually high or unusually low. Well, this one is pretty much spelled out for us as test 5. Let me just mark off as I go. Okay, so test 5, right? It even says it right there. 2 of 3 observations in a row on one half of the chart and in zone A or beyond. 3 examples are shown. So just to remind you, right here to here is saying you're 1 standard deviation from the mean. And then here to here would be 2 standard deviations from the mean. And then here to here, we're saying 3 standard deviations from the mean. So we're saying, okay, well, if we see that we have 2 of 3 in a row that are in zone A or beyond. So here to here, we expect 95% of our data to fall in this spread of values. So if we're seeing 2 of 3 in a row that are beyond that, so here are 2 in a row, 2 of 3 in a row, 2 of 3 in a row, 2 of 3 in a row, right? Then that means, well, again, red flag, investigate further. Why are we seeing 2 data points that are so unusual out of 3 consecutive points? Okay, one other thing just to point out here while I'm looking at it is that it goes out of control on that third one. So we're looking at 2 of 3, and it's on that third observation always that it's out of control. So here we see we're on the same side of the center line, and we have 2 of 3. Here's that third point where it's out of control. This data point is meant to be just on the center line. So we're not really on one side or the other, but here, 1, 2, here's that third one. That's when it goes out of control, and then boom, 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 third one, that's when it goes out of control. So C is 5. Okay, next one also pretty self-explanatory because it's listed right here. That's test 6, where here we're looking at 4 of 5 observations are all somewhat high or somewhat low. So going over 6, why is that the case? Well, again, we're seeing that here to here would be within 1 standard deviation of the mean. So if we're seeing that we have, 4 of 5 that are really in zone B or above, here's zone B or below, slide that up a little bit more, then we're seeing, oh, that seems pretty unusual because we expect 68% of our data to be in between these markers right here and here in zone C. All right, for E, the mean seems to have decreased or increased. So we're just looking at a change of mean. So the change of mean should be in number 2. All right, so in number 2, the change of mean, boom, we have 9 observations in a row that are on 1/2 of the chart, right? So if this is what my mean is supposed to be, then I can see that it's shifting downward here because I have 9 consecutive data points in a row that are on one side of the mean. So it looks like the mean here is shifting downwards. If I had 9 consecutive points that were on this side, then it would have been shifting upwards. And we're calling that big red flag on day 9. So on that 9th day, that's when we get our warning sign that our system is out of control. All right, for F, the standard deviation has decreased. Okay, so where has it decreased? Where do I see the least amount of variation here? And that has got to be 7. Okay, so looking here at 7, you can see again, the bulk of our data should be here, right? That is 1 standard deviation from the mean. So most of our data, 68% of it, should be tightly packed together in zone C, because that is, again, 68% of our data should fall there. So here we see that our data is nicely packed together around that center line. It's not necessarily a bad thing, but it does mean that we should maybe recalibrate and adjust our standard deviation accordingly, because it seems like our standard deviation has shifted ever so slightly, right? We have less variation than we had previously. All right, so that's test 7. Crash, crash. All right, I think we're okay. All right, next is standard deviation seems to have increased. So where do we see a lot more volatility? Where do we see some erratic behavior over a period of time? So here, standard deviation seems to have increased. That would be 8. So why does that signal that the standard deviation has changed? Again, because zone C right here should be 1 standard deviation. I don't see any data points that are in zone C, and that's where I expect the bulk of them to fall. So here we're seeing, again, when there's a change in standard deviation and it's increasing, we are seeing more variation, more highs and lows. And being specific here, we're saying 8 observations in a row, none are in zone C. So that red flag comes on that 8th observation, where we have our 8th data point in a row where nothing is in zone C, where that's 1 standard deviation away from the mean. All right, lastly, what's left over? The process shows a non-random pattern that should be explained. Okay, so that would be our last one, 4. right, so looking at 4, why do we say that's a non-random pattern? Well, it looks like we're seeing someone who has made it go high, low, high, low, high, low. So to me, it's like when I have you guys flip a coin and I have you tell me, your coin tosses. What does it look like in your head versus what does it look like in reality? So if you were going to fake a set of data, you tend to make things alternate a lot more typically than to give large runs of the same number. So for example, if I'm flipping a coin, you guys often think that we're going to have heads, tails, heads, tails, heads, tails, head, head, tail, tail, something like that, when really longer runs are more common. So here it kind of looks like maybe someone faked the data if we see alternating ups and downs over a period of time. Or what is really explaining that up and down? What's causing it to be up and down? It seems suspect, so we get a red flag on that 14th observation. So if you look at it, we see that starting here, right, maybe that other data point was somewhere above it, but from here we are looking at its alternating up, down, up, down, up, down, and then on that 14th observation, that's when we call the red flag and say something seems out of control. All right, so again, this is day 1 of control charts. I think it's pretty interesting, definitely a good quality control application, and I will give you this chart to use on your homework and as well as on your next exam. So you just have to make sure that you understand what it's describing to you, what it all means, and you'll have some good practice problems tonight for your homework. All right, I hope you all have a wonderful rest of your day.